We want to find the Taylor series expansion for cosine of x centered at c equal to 0. And this is the Taylor series expansion formula. And so first, we'll find the first few derivatives and then look for a pattern. And so the function here is cosine of x. The first derivative is negative sine of x. The second derivative, the derivative of negative sine of x is negative cosine of x. The third derivative is sine of x. The fourth derivative is cosine of x. The fifth derivative is negative sine of x. And the sixth derivative is negative sine of x. And then for each derivative, we evaluate it at c equal to 0. So f of c or f of 0, which is cosine of 0, which is 1. The first derivative at 0 is negative sine of 0, which is 0. The second derivative at 0 is negative cosine of 0, it would be negative 1, since cosine of 0 is 1. The third derivative is sine of 0, which is 0. The fourth derivative at 0 is cosine of 0, which is 1. The fifth derivative at 0 is be negative sine of 0, which is 0. The sixth derivative, which is negative cosine of 0, which is negative 1. So the pattern is going to be 1, 0, negative 1, 0, 1, 0, negative 1, 0. And then this is our formula right here. And so in the place of f of c, we have 1. In the place of the first derivative, we get 0. The second derivative at c, we get negative 1. The fourth derivative, we get 0. The fifth derivative, we get 0. The fourth derivative is 1. And then the fifth derivative, we get 0. And the sixth derivative, we get negative 1. So all the odd powers derivatives will be 0. So the first derivative be 0, the third derivative be 0, the fifth derivative be 0. And then the pattern is going to be 1, negative 1, 1, negative 1. And here's the Taylor series expansion formula again. And so here we get 1. First derivative we get 0. Second derivative we get 1, negative 1. Third derivative we get 0. Fourth derivative we get 1. Fifth derivative we get 0. Sixth derivative we get negative 1. And so we'll end up with 1 minus x squared dividing by 2 factorial plus x to the fourth dividing by 4 factorial minus x to the sixth dividing by 6 factorial. And so the pattern is going to be positive, negative, positive, negative, positive, negative, and so on. And the nth term formula is going to be negative 1 to the n times x to the 2n, because all of the exponents here are even. And then here we have all the positive integer factorials, so it's going to be 2n factorial. And so in summation, using summation notation, and then f of x, which is the cosine of x, is going to be summation from 0 to infinity of negative 1 to the n times x to the 2n, and then dividing by 2n factorial. And then we can check this formula right here. When n is 0, then we get 0, 0, 0. So this will be negative 1 to the 0, this will be x to the 0, and this will be 0 factorial. Negative 1 to the 0 is 1, x to the 0 is 1, 0 factorial is defined as 1, and so we get 1. and that's this one. The next term, when n is 1, we get a 1 here, we get 2 here, and we get 2 here. So it'll be negative 1 to the first times x to the second, dividing by 2 factorial. So this will be negative x squared dividing by 2 factorial. And so we have negative x squared dividing by 2 factorial. When n is 2, it'll be 2 here, 4 here, and 4 here. And so we get negative 1 squared, which is 1, positive 1. And then x to the fourth dividing by 4 factorial. And so that's going to be this term. And so this n term formula works out. And so in summary, this is what the Taylor series expansion for cosine of x comes out to be. So cosine of x is equal to 1 minus x squared divided by 2 factorial plus x to the fourth dividing by 4 factorial minus x to the sixth dividing by 6 factorial, and so on. And this power series right here, it converges for all x.